Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that consider 0.45 moles of water. Okay. And they say calculate the number of one water molecules present. Okay. How do we approach this? Okay, let's start with one water molecules. Okay, so here you have to use the approach of this relationship put forward by Avogadro. It says that number of moles is equal to number of water molecules over Avogadro number. So from here, what do we have? We know number of moles, which is 0.45. Okay, we are looking for N. N, we are dealing with a molecular compound. So N is the number of molecules. And divided by what? By Avogadro number, which is 6022 times 10 power 23. Okay, from here, what do we get? After cross multiplying, we are going to get our N as 0.45 times 6.022 times 10 power 23, giving you so this is what you get. And these are molecules, because we are dealing with molecular compound. Okay. Yeah, now next we come to number 2, which says total number of atoms present. Okay. And how do you deal with this one? What you do, you quote our relationship. What does it say? It says that number of moles is equal to the number of molecules. We are dealing with water, which is a molecular compound. So it's number of water molecules over Avogadro. This will give you, let us look at here, number of moles is 0.45. And number of molecules is N divided by Avogadro, which is 6.022 times 10 power 23. What you get after cross multiplying is going to give you N, which is equal to 0.45 times 6.022 times 10 power 23, giving you okay. So this is what you get. But we must not forget that these are number of molecules. And the question wants total number of atoms present. So from here, you have to go back and check. This is what you have to be reminded, that a water molecule is this, and it has 2 hydrogen atoms and 1 oxygen atoms. Total we get out of this is 3 atoms. So each water molecule contribute 3 atoms. So this is, after that, what we do? Here we can say that 1 molecule contains 3 atoms. Okay, so these are the molecules you have. So in other words, 2.7099 times 10 power to 3 molecules will contain X. So from here, after cross multiplying, what are we going to get? We are going to get X is equal to 3 times 2.7099 times 10 power 23. Yeah. So this is what we get. So this is the total number of atoms present. Yeah, then we come to this one. Number 3, which is calculating total number of hydrogen atoms present. Okay. How do we approach this? Well, you have to remember that 0.45 moles are of water molecules. So the approach is to have our relationship, which is number of moles equal to number of molecules. We are dealing with a molecular compound over Avogadro. From here, you substitute. Our N is 0.45, and our number of molecules are wanted, but we know the Avogadro number, which is 6.022 times 10 power 23. From here, what do we get? After cross multiplying, we are going to get our N as 0.45 times 6.022 times 10 power 23, giving you giving you this. But you have to remember that what we have here are molecules, water molecules. And you need to know that our water molecule, which is H2O, gives us 2 hydrogen atoms. So in other words, what do we say here? 1 molecule of water there is 2 hydrogen atoms. Yeah, that's from the formula. So in other words, these are the molecules we're having: 2.7099 times 10 power 23 water molecules will release X. So from here, what do we do? You cross multiply, and you are going to get our X as 2 times 2.7099 times 10 power 23, giving us this, which is 5.4198 times 10 power 23 hydrogen atoms. Yeah, then we come to this one, calculating the number of oxygen atoms in this. Okay, remember we have 0.5 moles of water. Water is molecular. So what do? You apply our equation. It says that N is equal to N over Na, where N, small n, is number of moles, N is number of molecules. Water is molecular, and this is Avogadro number. So when you come to substitute, what do you get? You get 0.45, giving you N, which is the number of water molecules, over 6.022 times 10 power 23. So you get n by cross multiplying, and our n is going to be equal to 0.45 times 6.022 times 10 power 23, giving you this. So what you have here are water molecules. So these are molecules. And the question wants number of oxygen atoms. What do we do here? You look at our formula. The formula is H2O. And from the formula, it's clear that whereas 2 hydrogen atoms are coming from this formula, oxygen is 1. So 1 molecule of water has 1 oxygen atom. So the number is the same. So what are we going to say here? That 1 molecule of water release 1 oxygen atom. So, which means that 2.7099 times 10 power 23 water molecules will release the same. Yes. So, in other words, the number of water molecules is the same as the number of oxygen atoms present. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to share. Yes, we believe we are being helpful in this aspect. See you next time. Bye-bye.